Damie's finally streaming on my day off. This is the first time you have? Well, I was flying. Well, okay, not flying. I was moving. So, come on. Normally I'm gonna stream on Sundays. But, yeah, I had to move first. Here we are. I moved my camera. Actually, I probably should move my camera. No, it's just like my face might get a little weird when I look at chat. Well, I'm actually looking at chat now. But yeah, I switched my monitor because I was like, I feel like it's better. It is a lot better cable-wise over here, so hopefully it all works out. This is not what we're starting with. We are gonna start with, let me see if this guy actually posted the problem for this, because he described it in class, so I remember what it is. I don't really need it, but it is math, surprisingly. I know I never do math, right? Well, it's kind of math. So, from what I remember, the idea is that it's for strength and stiffness. So there's a class about defining... Why is my gain so high? Jesus Christ. It's about defining... It's not really getting lower, is it? It's getting a little lower. Let's put it down there. Let's put it there. This is a class designed for strength and stiffness. You're trying to do some numerical solutions to different systems so that you can put different loads on them, different stresses, and figure out where they're gonna fail. So one of the things that we talked about, even though it wasn't very good, sorry, I can't keep clowning on these guys. What if they see? What if they see my... Well, we were talking about the different shapes to make up meshes. So for me, it's actually really not that different because I started with mesh modeling. So when you have a 3D object in SolidWorks or something, you kind of use vectors and you extrude those vectors. So if you wanted to make a cylinder, you would make the cylinder sort of like this, right? And each one of these, if you zoomed in really far on this, this would still look like a rectangle, or not a rectangle, Jesus Christ, not a rectangle, an ellipse. But with mesh modeling, it's kind of like the difference between vector versus raster. So we're gonna use other shapes to make up these shapes. And the shapes that we have at our disposal are this, which is called a linear triangle. And then we have a linear quadrilateral. And then we have fancier ones, which is the quadratic triangle. So it has extra vertices here. And the quadratic quadrilateral. So we need to use these, but I mean, at the end of the day, it's just like we're either using squares or rectangles. So in that vein, we're supposed to figure out how many nodes, so each polygon is called a node, how many nodes we want to use to make up a circle. So we're going to be using triangles to make up the circle. And when he did it, he said that the sides of the triangle, like this, were touching the edge of the circle, but for the one we're going to do, the middle of the triangle is touching the edge of the circle. So ours is actually going to extend out and over correct the area here. Also, it pissed me off because he asked us, he said, okay, so in these deflection programs, do you think that the deflection overcalculates or undercalculates the amount of deflection, the algorithm? And I said, well, I think it would be good if it overcalculated, because then we would always know that we're overestimating what our stress is, and then we would never have to worry about going over it. And I said, but it kind of just depends on how you do the algorithm. And he was like, no, it's always going to undercalculate because you have less degrees of freedom. And I was like, okay, but if you understand this, like if you have a beam, right, and the beam bends, and let's say you have the beam bending like this, you could have this, right, and like if you put a load on it, you say, okay, this point moves down like whatever. You could just put like a factor on it so that it moved down like this much for the load, and that's just like depending on how you program it. So I was kind of pissed because I'm like, I'm not saying that that's necessarily what happens in real life, but when you're coding something, you could just put a factor in it. You could multiply every number by 3 million if you wanted to. That's your algorithm. I don't know what their algorithm is, like... He was like, no, because of the physics. I was like, bro, I don't know what to tell you, like... Like, unless you want to define the algorithm for me, and then... Oh shit, I don't have any toggles on. Oh, I forgot I don't have that one. Let's... This one's gonna block. Let's do this one, and we'll do that one. There we go. No earring. Anyway. It's just geometry, really. But, I don't know, geometry's comfy, it's math. Wait, let me pause my vlog. There we go. Yeah, the joke in the title is because... Okay, I'm not gonna explain it. You get it. You get it. You get it, chat. You're smart. My titles are just unhinged lately. People keep, like, finding me on YouTube lately, and I'm like, oh my gosh, this is crazy. But then I look at my titles and I'm like, oh, I'm so sorry. So... Well, this really isn't too hard. The question is, so if, let's say if we have n equals 1. Well, that wouldn't really work. What's the smallest number we could have? 2? No. 3. I think it has to be 3. Is our smallest one. Right? N equals 3. That means that theta equals... Well, let's define theta. So this is theta. Theta equals 360 divided by 3 equals 180. No. No, it doesn't. No, it doesn't. Oh god. 120. It was close. It was close. It was close. It was close. Yeah, because if we had 2, then it wouldn't be a circle. So then theta divided by 2 equals 60 degrees. And then we just have to say that we know that this is R. And we want this side. So... Is there something else I need? Am I tripping? How would I do this? Well, what side? I want this one. No, it's just cosines and sines. So... If I want to get this length, which I don't really need, we can say that I'll just call this L. And this is B over 2. So L cosine theta over 2 equals R. Yeah, I feel like that's okay to say. And then L sine theta over 2 equals B over 2. So... You do evil math? Like math for evil purposes? Or math in an evil way? Or me just being evil? I mean, I could just be doing evil math right now if I'm evil. Math in an evil way. I'm gonna make all my variables numbers. So 3 over 2. Oh wait, this is just law of sines and cosines, isn't it? No? I feel like I'm actually doing math in an evil way. This feels like not right. But this is L, and this is... No, wait, sorry. I can't do that. I can't. That's too evil. I'm an angel. I can't do evil math. So R tan theta over 2 equals B over 2. I think that's right. Maybe... Should I check this? I feel like I should check this. I also need my calculator. 1 second. Well, we're gonna do this in MATLAB in a sec, but I should get my calculator. Let's do some... Should we just do this in MATLAB and not even bother with this stuff? Because I got the formula, and then we just have to do the formula. Let's just do it in MATLAB. What the hell? I don't want to put it in a real calculator. Just loop it. Okay, this is actually good because I need to like figure out how to like add variables into an array on MATLAB. I think there's an append or something. Who's Matt and why am I using his lab? It should be, I think that's right. I think that's right. If I plot it, it should work out. I think I only need to plot like 20. So we'll start at 3 and then increment 1 and 20. I'm gonna need to remember how to write a loop in MATLAB. Okay, I know how to write a loop in MATLAB. But it's a little bit, the way they have us define it is they usually have us loop through an array. It's like, it's not normally how I would loop in any other programming language, so I have to remember the syntax. Alright, let's make a new one. Called, what is this? Called... I'm gonna save it as... STR STIFF 1. That works. Oh. I forgot, you can't have spaces in it. There we go. Failing the first test. Here, let me pop this over. I lied. Let's go over here. There we go. Yeah, we're chilling. Okay. So what do we need to do? We need to make a value. We need to make an array. Which I guess I define a blank array in MATLAB. It's not really super... Well, okay, it says here's an empty array. I forget if you have to specify... Oh, no, it's just this. Okay, so we're gonna call this... Areas? Areas. Okay, so we have a blank array of areas. We want to say for n equals 0. N equals 3. For loop MATLAB. Or n equals 3 to 20. I'm just gonna say like, hi. No. End. Okay. Now. We need to say theta equals 360 divided by n. We got that. That's good. And then we'll be using theta divided by 2. So now we have to say that... I guess it's just r is r. R is supposed to be 1, maybe? I mean, I guess I could just call it r. Let's just call it r. R equals 1. Then we say... b equals 2 times r times tan theta, because I did theta divided by 2 is the... No, I lied. Theta divided by 2. And then areas... Do I want to maybe set it up so that it's like 1 and this thing, and then 2 and this thing, maybe? Can I have it be like 1? No, I don't want to do that. I'm just gonna have it be like areas n? No, because it can't be that. I need an iterator. I'll say I equals 1. Areas I equals 0.5 times base times r. 5 plus plus. Can I do plus plus in MATLAB? Doesn't look like it. That feels so lame. Oh, it's like kind of cut off. Oh, that's not it. Wait a second. Move this way. Okay, let's see what that does. And then just like display. Okay. Invalid. Oh, when calling a indexing a variable. Whoopsies. Wait, what? I feel like that's wrong also. Variable appears to change size on every loop iteration within a script. Consider pre-allocating for speed. Okay, I guess I could do that. How do I specify an array with a certain amount of values? Create a 0 by 0 array. Here we go. I guess I could do 0 by 0. Well, I guess I could. No, I don't want to do that. I'll do zeros. And then I can set up the pre-allocation. So we'll do zeros. 1. Let's see, what is it? 17? No, 18? Just 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17. I think it's 18. Let's see. Oh, we got something. Why did I stop? Okay, first off, put a semicolon there. What happened? Does I not... I want to keep going. Wait, it's... Why is it not setting I... Okay, really quick. This is really not great. Oh, actually, wait a second. I can just do this. Maybe that'll show. Wait, why is it equal only 2? What the fuck? Why did it stop doing that? What? Oh, because I set it equal to... Oh my god, guys. I'm losing my mind a little bit. There we go. Okay, so why are we getting some negatives in here? I don't think my formula is right. That is not right. It should be converging. Okay, let's do a plot. Plot. Let me make an n. N equals 118. Or 117. Plot n areas. Actually, I don't know if that's gonna work, but let's just see. Hello? Do I need to, like, specify the line? R dash... R dash, maybe? Nope. In a while, MATLAB lot marker specification. Dash dash O. Try that. Maybe it just wasn't plotting anything. What? What is N? Where's N? N is just 20? Hello? Can I see what N is? N's gonna be like nothing. Wait, get rid of I. Wait, where's I plotting? Oh, wait. Areas. Areas. N. Yeah, wait, that shouldn't be... Wait. Why is it flipped? Areas is supposed to be... This is the X and that's the Y, right? Why is it flipped? Hello? Also, K. Alright, try that. I don't know if it's gonna be... Yeah, okay, that's a little better. Okay, clearly the tan is wrong, so let's go back. Let's go back to drawing board, guys. Okay. Something about this formula is not right. L cosine theta over 2 is R. That's right. And then L sine theta over 2 is B over 2. Which is right. Let me just try and do this instead. We know that... Where'd my pencil go? What? Hello? What? Oh, here. Let me get rid of this. We know that tangent equals opposite over adjacent, so if we have L tangent... I guess we don't have L, and it was like being recursive. B over 2 R. Yeah. Yeah, we don't know what L is. Is there any other way that I could figure out? Because I just have R. Oh, well... I know what R is, but I still have two, yeah, I still have two unknowns, which is this and this. Because if I try to get R equals, or let's try to get like B over 2 in terms of other stuff, you get an L in there. But how can we get L? Well, I mean, we know that... Well, maybe I just say this. L cosine pi over 2... Oh, whatever. Sorry, not pi over 2. Theta over 2 equals R. So L equals R over cosine theta over 2? Which means that you get R... Is that like an issue? Let me see. It doesn't look like an issue right now. Yeah, because this shouldn't be an issue. So B over 2 equals... Or B equals R squared over cosine theta over 2. Tangent theta over 2. Yeah, definitely a little more complicated than what I had before. Well, tangent is sine over cosine. But yeah, I don't really need to deal with that. And then just times 2. Okay, let's try this formula instead. I'm just gonna keep you guys over there for a second while so it's R squared while I input this so I can... And then divided by cosine theta 2. Alright, let's see. Crossing my fingers. That didn't change it at all. I don't need N to show. Let me... Wait, I just deleted it. I want that still. Why is it not showing areas? Oh, because I'm not displaying the areas. Jack, this is not it. Theta equals 360 divided by N. Maybe I should check on theta? Wait a second, but N is... Oh, maybe it's not doing this. Let's try this. Num. Yeah, I might have actually messed up on that. Uh-oh. Vectors must be the same length. Okay, so... Let's see. From 3 to 20, or from 1 to 20 is 21, right? Or am I just like really being dumb right now? No, because I'm starting at 1, so this would be 17. Oh, but N should start 3 to 20. Okay, okay. Oh, there we go. Okay, you can't see it. It's definitely not right. But it's... Wow, that's really wrong. That's really wrong. How is that so wrong? Why am I getting negative 15? Wait, what? The what? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Wait, but also it's like, I don't know why the scale is off. There's like ones that say they're down at negative 60? Where? Hello? I don't know why it's doing that. Like, can I look at areas? Wait, yeah, the areas are way bigger than the... Wait, no they aren't. Well, there's a negative... Wait, no, the negative 60 is right here. Why is there a negative 60? What the heck? Okay, the formula is just like wrong for sure. Okay, maybe if... Let me put this on shuffle. This is my sad music. Why is my sad music on right now? Sorry. Okay, well, the area should also be times 2, so that's one thing. Because it's 2 of those things, because I split it in half. Well, 0.5 times 2 is just 2, so it's base times height. Let me do that, and then I'll put a comment in here that says like... Oh, that's not a comment. What's a MATLAB comment? That's not a MATLAB comment either. Is it this? Nope. What the... What? I can't even... Oh, it's a percent sign, because of course it is. Okay, this is because 0.5 times 2 equals 1, 2 triangles. Sorry, I'm just adding a little comment for me. Alright, what if I try and draw this? Okay, so let's do that. Here, here, and here. So this is our little thing that we've got going on here. We know this. It's gonna be like this. Let me just do the bottom one. We know that this is the radius. We don't know what this is, and we don't know what this is, but we know that this is theta divided by 2. So we're trying to find this. We don't really care about what this is. This is what we want. So we could do... Wait, why was I multiplying by L? It's just tan theta. Opposite over adjacent equal... What the... Oh my god. Okay. Okay, let's try that. I don't know why I was doing all that. Why did I say L? It's just that. Okay. Alright, learn by doing. We try things here. So it's literally not even hard at all. It's not all this garbage, there's no r squared, it's just 2r times tan theta over 2. Okay. Now let's see. Why? Oh, there we go. Invalid expression. Oh, because I didn't put 2. Alright, it's weird still. It's not supposed to be like this. It's supposed to, like, not be... How are we getting 15? How are we getting negative 12? Is this because theta's weird? Maybe it's something with the input to this that I need to, like... Because theta should be getting... Okay, what if I do this? Let me like, display theta. Theta should be getting smaller. Yes, theta's getting smaller. That's good. Why is it being so weird, then? Does tangent have a weird switch thing somewhere? Do I need to, like... Wait a second. It's in radians. Oh my god, this is perfect. Well, there we go. Okay, well, we got that. That's good. Oh my god, chat. It's in radians. It's in radians. Now I have to... Okay, we have to do one really other quick way of doing this, which is we have to do the... If the edge of the triangle is the radius, not the middle of the triangle is the radius. Not the radians degrees switch. Oh, that was a rookie mistake. Oh my god. That's crazy. That's crazy. Okay, so this is R. And then this is theta over 2. Okay. So we still want this base, but then we just have to say hypotenuse over, well, we can say that R sine theta over 2 equals b over 2. So then b equals 2r sine theta over 2. Yeah? Yeah. So let's go back to MATLAB. I will call this outside areas. And the numbers will still be the same. And then instead of this, we're gonna say, we're gonna do the exact same thing. We're gonna make an inside areas. And that will be fine. Oh wait. Oh yeah, lol. I just like seeing arrays. Sad. Okay. So be outside. Boutside. And then this one will be inside. So we redefine this to be inside. And we say this is inside areas. I love this song. 2r sine d. And then if we hold on and we number plot, let's make these ones in red and these ones in blue. And we plot this as inside areas. We don't need to display outside areas anymore. We also don't need to display theta. Let's do that, and then that, and then that. That's pretty good. That's pretty nice code. Okay, so we did something wrong. What's wrong? What's wrong here? One's supposed to over approximate. Well, actually, no, wait, no, we did it right. We did it right. It's just our scaling is weird. So we have to set our scaling correctly. We want to set our middle line, I guess, at pi? So we're trying to approximate a circle. Oh god. Do I open my MATLAB? Or do I open regular MATLAB? Lots in we're gonna open MATLAB. Maybe there's like a master thing that I can look at to change all the different stuff. Create a line plot from matrix, specify line style, yeah, specify line color, specify markers, don't need that. What about axes? What about axes? Titles, plot durations, plot coordinates. I want to know. I just want to know how to fix my axes. Axes. Or I guess maybe it's not called that. It's called... What's it called? Like range, I guess? Set range. Set Axis limits, matplot, matlab, matplot. There we go. Xlim, Ylim. I remember this vaguely. Can I say after, or do I have to say before? It feels... it's weird, you say it after. So it's gonna be from... I don't know. We want the middle to be pi. So let's say... 1... Wait, no. No, I just want the Y limits. I don't care what the X limits. The X limits were fine. X limit is gonna be 1 to... Wait, 2 to 4. Try that. Okay, that did not work. What? What? If I get rid of the Y limit? Oh, because it's really underestimating it. Wait, what? Wait, whoa. Why does it say 0.5? Wait, why are there asymptotes to 0.5? They're supposed to go to 3.14? Hello? Wait, why are they going to 0.3? Wait a second, I didn't even notice this. Did I... Oh, because I didn't say, like, times n. Where's the areas? Times n. There we go. Whoopsies. Now if we run it. Oh, yes. I'm not sure about that, actually. Wait, how do I plot a line? Plot an axis line. MATLAB. Add lines along the axis. What? Oh. Yeah. I guess I could just do that. It does it at 0, but I'll do it at X limit is 3.14. Wait, no, I want Y limit. Oh, whoopsies. It's fine. 0, 0. Pi. I'll just do pi. See if that works. It did not work. Oh man, come on, man. Wait, also, why is it so high for the first one? The first one's so high. Also, why is it 6? It's supposed to be n divided by 2? Okay, so what happens is we divide it by n. And then, yeah, for both, it's like 1/2 base times height, but it should be 2 in 1, because we basically did the isosceles, the right triangle, instead of the equilateral triangle. Right? Right, chat, please? Yeah, because we used theta over 2, we didn't use theta. And then we have to double that, and then we have to double it again. But, like, why? I don't think that's right. Okay, I'll figure out how to do that later, but let me display the areas. Wait, I guess I don't really need to display area. We can just, like... You can't see the plot, but I can look at one of the points. X equals 10. At the end... Oh. At the end, Y equals... Yeah, it looks like it's, like, going twice. But why is that twice? Is it because I double counted, maybe? Maybe this, I mean, if I do n divided by 2, it should probably give me 3.14, but that's really kind of a bad... Yeah, it's gonna give me 3.14. It's close to 3.14, which is fine. But, I don't like that I don't know why I need to divide it by 2. Because we have the 0 point... This is one of our triangles. Right, is this. And then times n, but n is the big triangle that we have, no? Maybe it's something to do with this 2? Oh, because I said 2. Base is 2 times it. Yeah, okay. Yes. Because we used the base. We used the base of the whole thing. Oh, really? I shouldn't have the 2 here at all. It should be this. So this is just one of the triangles, and then this should be this. And then we'll do this. We'll say base for half of a triangle. And then we get rid of the 0.5 here, and we run it. And it's right. Okay, cool. So now I have to plot somehow a line on the x-axis, which, I'd draw an axis line. You make a line. Okay. Yeah. Y limit 3.14 pi. Maybe pi doesn't work. Yeah, maybe pi doesn't work at all. 3.14159. That should be close enough. No, it just doesn't work. What? Oh, is it because I didn't hold on enough? What if I did this? Run now, run. No, it doesn't. What? It hates me. Is it too small to see somehow? Like how I've run it this many times. What the hell? Is it 0, 0? Is it because it's at 0, 0? Would it be at like 0, 3.14? 159? Maybe that's why? No. No, bad lab. Please! Okay, axis line. Sorry. This is what the intermediate dynamics is gonna be. Genuinely, this is x line 0, y line 0. Okay. That's what I want to do. X, we want a line on the y axis, so y line 0, or 3.14. Try that. Maybe I wasn't putting a semicolon. Okay, that instantly worked. There we go. Y line. Alright, so that's our... It's interesting because the... let me see if I can show you guys the image here. There we go. So this is the figure. It's kind of interesting because the red one way over approximates versus the blue one, which is the inside one. I should probably make a legend. The blue one doesn't under approximate as much, I guess, which is kind of interesting. The red one is like all the way up here at 5.1 versus 2.59. But I guess it kind of makes sense because if you draw the lines between it, it kind of doesn't it's not as off if you're drawing it inside versus if you're drawing it outside, then it's more off, you know? You know what I mean? Maybe. Okay, I guess I'll do a legend real quick. Legend in MATLAB. Oh, I should probably put axes titles on it. So what is that? X-axis? X-label? X-label is number of nodes. Maybe I should capitalize that. Number of nodes. And then Y-label is area of... approximate area of circle. Circle, radius 1. And then legend, okay, cool. This will be R equals, so the first one we did was we plot the outside areas, so R midpoint, yeah, midpoint on circle, and then leg on circle. Is that gonna make any sense? I say the leg on circle. I feel I feel like that's an insane thing to say. Oh, whoops. Wait, the over approximation is... Wait, why is it not... Oh, because I did the Y line first. Whoops. Do that there. Yeah. Yeah. I think that's all I have to do, and I can print out like the accuracy versus if I want to have a little thing that's like accuracies, and then I can just do dot divided by whatever. I can do a little, what's the, you know, the thing, the math thing, the experimental data thing. Okay, that's all good. I'm glad. I was really going through it on the, I was going through it on that one a little bit. Alright, so that's all done. All nice and neat and sorted. So let's do thermo. Let's do some thermo. I really should like flash a big picture up when I change, or maybe I should like, I don't know, change like the color or something when I change subjects, so I can, when I edit these, it's easier for me to do the sections. So I'm really just going to quickly knock out these last three of the number of pound moles and 50. Wait, pound moles though, in 50 pounds. So we have to find, that actually I probably don't have. That might be an appendix thing. I have K-mole, but I don't think I have pound mole? Because who uses pound mole? Yeah, these are all K-mole. Okay, we'll have to use that textbook. Did I download it? Let me see. We can go on an adventure together, chat. I probably did download it. Let's see. Maybe I didn't. It'd be in workplace. That's EE. 328. Yeah, I guess I don't have it. Maybe, wait, maybe I put it in here though? What was it called? I forgot. These are supplemental handouts. Oh, there's a thermo edition? Damn, I didn't get the thermo edition. Wait, I think I did get this. Maybe I didn't. No, I don't think I did. Okay. Where is this? Maybe in documents? Man, I don't want to download again. Maybe I just didn't download it. That kind of sounds like me. It'd probably be better to... well, actually, this guy might make me buy this textbook, so I don't want to download it. Get out of here, man. Is it up in Firefox? Maybe it's just up in Firefox. No, it's not. Fine, find it. Maybe if I search therm... No. Maybe? No. Sorry, I got excited. That means I have to like go to Bolivia. I should really just bookmark this page. Thank God for Reddit. Reddit answers. What is it? 302? I hope it's 302, otherwise, yeah. We need the 7th edition, I believe. Specifically. For whatever reason. Okay. Let's go on a journey, chat. Why is it Papa's? Okay. Did it go? Did it go? Oh, it didn't go. No, it's the wrong one. There we go. It was late in the book. It was through 9,000 something. Oh, not that far. Probably higher up. Wait, it's at the table. It says A1 and A1E. Okay, A2E. Hello? Can I get a a load, please. A118? Why is it not A1E? Wow, these tables are... There's too many of them. There's way too many. He said he wants us to bring all of these tables. I'm like, dude. Is it gonna kill you, really, if we don't look in this specific... Like, I know how to use a table. You look at the table and you find the value. Why don't you just use one instead of... Put in preview file. Chat. Chat, am I cooked? I don't want to download it. I might have to download it. Is it in my PDF editor? Maybe I can open recent. Recent. No, that's EE. Okay, I don't think I downloaded it. Damn. Oh, there's an image to PDF generator on this. Oh, I didn't know that. I just use a website. Maybe it loaded now. Oh, what if I just looked it up? It probably wouldn't be different. It's just periodic table stuff. Please, please. This is the table I need. Fine, I'll download it. Oh my god. Oh my god. Anyway, back over here. It doesn't even want to download it. Oh, oh. Oh, by the way, for that dynamics problem, I'm just gonna wait and see. Oh, I guess we could do the state. Let's do that a little bit, just so I don't have to wait on this. There's one little last thing I have to do here. Show the state space representation. So we have to convert this into from a second order? Well, I guess it's... Wait, where's the differential equation? I guess V? But that's a first order differential equation. Oh, F equals MA. Oh, never mind. Never mind. The notice. Okay, A equals CV squared. There's our differential. What am I even talking about? I'm being silly. Okay. Of course it's right there. Alright, so A equals CV squared. So if we write this a different way, that's X double dot equals CX dot squared. Now I'm gonna have to look at how we're supposed to do this, because we have to just turn this into a system of two linear differential equations, or two first order differential equations. It's already linear. Well, is it linear? Oh, it's not linear even. Okay, we're gonna try our best. Do my best here. Let's see. Oh wait, I need week 1 handout, and then numerical methods? The end of numerical methods, I think. Yeah. Okay. So we're gonna... First off, the solutions to this differential equation are gonna be x dot and x. So first we just start off by saying we have x dot and x are our solutions. And then if we take the derivative of them... Okay, let's do this instead. x1, x2 equals x dot. Wait a second. Wait a second. Okay, they're kind of... So they have this. me rewrite it. I'm a little confused about this notation. So ddt, I like that. We're taking the time derivative of x and x dot. That should equal x dot and x double dot. Yeah? Okay, we like that, chat. We like that. Now, x1 equals x equals position. Yeah? So x1 is position. And then they say that this is x1 dot, which I don't like. Well, so this is position. No, so I guess that's okay. That's okay. And then we have x2, which equals x1 dot also. Oh. Wait. Oh, equals x2 dot. Because x2 equals x1 dot? Oh, it's like reduction of order. Okay, maybe, okay. I'm getting there. The brain is turning. So then what they say is there's a specific, so they replace acceleration. Okay, so for ours, we have x double dot equals cx dot squared. So we're going to take this, we're going to change this into x2 dot equals c x2 squared. And then we have x, but where's x1? x1 isn't even in here. x1 dot equals x2? Okay, that's what we have. It's just weird because, so they did theirs with Hooke's law. Hooke's law has a plus x1, basically, in here. Or minus x1 or whatever. Alright, so that makes sense. You want to have one dot over here, and then you want to have no dots over here. But x1 isn't equaling anything. Well, I mean, I guess it's equaling x2. x1 dot is equaling x2, but there's no x1 in here. It's just nothing. Well, that's what they asked for. Alright. Good job, chat. We did it. I wrote it backwards, but that's what it is. Nice. Do I know how to input that into MATLAB? Absolutely not. But it's there, and I get it. Do I want to try it with... I wish there were more examples other than just one, but... that's what we got. We got one example. Alright, did the thermo thing download? If it didn't download... We're experiencing difficulties. Yes, I'd like to download it. Sorry, I have to answer a little things here. Okay. I think it's getting there. I think it downloaded. Oh, okay. This one, why is this one not done? What's happening? Use MATLAB? Oh, not MATLAB. I just read MATLAB. Wait, I found this one already. This one's fine. I did this one. What's wrong with this one? Did I goof up? No, I did that. Okay, I don't know why there's a star on that. Okay. This one... Oh... I don't know why the sign is flipped. Or, I don't know. That one's weird. Oh, wait. The stars mean they are done. Whoops. I was like, why are all these not done? That's fine. This one is the one that I We just need to get the acceleration on this one, so we'll do that. I don't know why this is. What if I just deleted it and then redid it? But I don't want to redo it. Oh, painful. It's fine. I'm gonna move these over here at least. We can do that. Given and fine, which I don't want to ever have to write, but it's fine. So we did that. VB equals VA. V respect to A. I'm assuming A is fixed, but maybe it's not fixed. Maybe that's why it's wrong. Wait a second, can A be fixed? Wait, A can't be fixed. A has to be moving. Doesn't it? Because... Yeah, A has to be moving. Oh, okay, so it's not 0. Okay, maybe that's why we were getting it wrong. Alright, let's try that then. So it's not 0, it's there's a VA, and then we have VA plus that. Oh, and that's why... Wait, chat, that's why we can't use that other equation, because there's a VA in there. Oh, there we go. It's because I looked at the problem wrong, of course. Plus VA, and VA is just going to be in the x direction, so it's going to be like VA, I don't know, what way do we think it goes? If B's going this way, then B's like here, and then this is like here. A's probably going to the left. All the sake goes positive, whatever. Alright, so then plus VA00 plus VA00, and that's why we can't use the cosine. Oh, that makes sense. Because I was like, oh, one of these is right, but the other one is wrong. Why is the other one wrong? And then it's wrong because the other one is stuck up in there, so it'll be right. There we go. Got it. So we have omega BA equals sine 30 over 0.15 cosine 20. And that's going to equal the it should equal 3.35 something. I don't want to have to type this in anymore. I typed it so many times before. I feel like I'm going insane over it. Yes, 3.55. And that's positive, so counterclockwise. Counterclockwise? Yeah, let's go. Oh, I'm so excited. And then we can just do the acceleration for this one, and easy peasy. And I don't even really need, I don't think I need VA. Now, I mean, I could find VA if I wanted to, but I don't really need it, I don't think. Because we're just gonna do the acceleration now. Oh, what a happy story. What a happy ending. I was just gonna be like, lol, I don't wanna figure out what this is. And then I would've looked at it and I would've been like, god damn it, that's so annoying. So in this one we have alpha AB crossed with RB with respect to A plus omega BA. I just realized that's not the same convention that I just did, but it's fine. BA crossed with RB with respect to A. And we did this one already. That's this chonky thing right here. When we write this out, we get... Now we do know the direction of AB is either, or alpha. Actually, do we know the direction of alpha AB? No, we don't. Oh well, I guess we, no, yeah, we do. It's gonna be similar to this one. Oh, I guess I should write VB here. Uh-oh, did I do something wrong? Oh shoot, wait, chat, we might have messed up. Oh wait, yeah. Oh, wait, yeah. No, ooh. Wait. This needs a magnitude. Oh wait, no, it's whew, it's constant. They gave it that. They gave us that. Okay. Yeah, I was worried. Wait, it's a constant speed, so it's 0. Okay, someone. Someone. I told them I would be late to this meeting, and they're messaging me. Please, I need to stream as a cat boy. What do I say? I say I'm coming, but I'll be late. Catboy time. Hey, they're the ones who made it 4 to 7. So like, you know, you're gonna make it 4 to 7. I'm gonna be like, I'm gonna stream for part of it. Sorry, no, I'm not normally like that. Okay, we don't know. We kind of know the direction of AA. It's like here, somewhere. We'll just say that it's positive. Why not? We don't know. AA. Oh, that's why that's freaking me out. There we go. Plus, and then we have I, J, K. I know what you're saying. Damie, please, for the love of God, just do the cross product in your head, and then I say, nope, we're gonna do it out every single time. Because I am a stubborn motherfucker, and if I want to translate this to MATLAB, it's gonna be so easy. Okay, that's my copium of the day. It takes longer, and it's more space on the paper, but I don't have to write out IJKs. So I say as I just wrote out IJKs. I know, but don't look at that part. Don't look at that part. Where's omega AB? Which one is omega AB? Oh, that one is omega. Or omega BA. Omega. Omega. Wait, did my music stop forever? Oh, it did. Okay. What do we got? 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 This one, the long one. Ooh, ooh. It's fine. You couldn't have just given us like, ooh, it's this many meters. 1 meter. Come on. Well, I guess things in real life aren't just 1 meter, but also things in real life you do with MATLAB. Or any other competent programming software. MATLAB is not the only competent programming software. No, there are many other ones. I just find the syntax of MATLAB is so different than any normal... I shouldn't say normal. We have I and J, so... Okay. Wait, that's not great. Wait, no, it's alright. Because we're gonna... Yeah, we're gonna have the omega A is gonna take out this one, so we're gonna use the second row only. So really I don't even need to do this I, but I'll do it anyway. So negative sine 20. And then minus that, but it's another minus, so it is minus sine 20. 0 plus. Do the same kind of deal here. I gotta stop crossing them out. That's a positive 0.15 cosine 20 omega AB. Squared? Is it squared? I think it's squared. Yeah. It's squared. And then minus, which is a positive, and then minus. Wait. What? What? Wait, what? Wait. That's probably right. I'll trust it. I'll trust it. Omega AB squared. There we go. So now we just have negative. Oh, they're both negative, so omega alpha AB equals 0.15 sine 20 times 3.55 over 0. No, cos 20. Thought it was gonna cancel out. Oh, I got excited. Minus 3. I guess I'll just use the exact value. That can be that accurate. Is that cosine 20 or 30? I feel like that should be 30. One of these should be 30 and one of them should be 20. Or not. Or not. Never mind. Not. Because this is the same. They're on the same side. 0. I don't know. This sounds wrong. 0.19. Fuck. Alright. God damn it. Okay, what did I do wrong? Could be a lot of things. Could be a lot of things. Did I... The 0.15 times 3.55 is kind of not super slay for that. For trying to get to a 4. That's what, it's tan 20? Sine 20 over cosine 20? Yeah, wait, but this divided by this? Wait, no, times that. Kind of nasty. Okay. Wait a second. Am I missing RBA? It might not be cosine, just cosine. Oh yes, because this is times... I forgot that dang 0.15 here. 0.15, so the 0.15s cancel out. At least. Wait, they're both on the same side of the equation. Oh, it's gonna be negative. Doesn't really matter. Maybe that's a little better? This time, times 3.55? No, 1.2. Oh, it's squared. Yeah, that would do it. Let's see. 4.58. 4.5. Wait, 4.5? What? 4.58? 4.6. Oh, chat, we did it. Chat, we did it, chat. Is it counterclockwise? Clockwise? I mean, clockwise. Oh my gosh. Oh my gosh. Negative 4.59 rad per second. Weird. Oh my gosh. Wait, that's so nice. Wait, we're chilling. We just did everything. There's some reflection questions I have to do. But, wait, that's so... Wait, we kind of like slayed really hard. Oh my gosh. It took a little bit longer than I would have liked, but also I didn't work on it for 3 full streams. So... You know. Kind of evens out. I emailed this one professor. Well, he's not a professor. He's a grad student. I emailed him and he hasn't emailed me back. Like, I don't know if he checks his email or not. I really kind of need him to check his email though, because I need to get into this class, Canvas, and I haven't gotten into it. Yeah, you know that like sinking fear where you're like, oh, the assignments are being due. It's fine. Alright, let me open this with the PDF here, and then I wonder if it has... Oh, it does actually have the chapters. That's so nice. Wait, we can skip right to the... We can skip to the appendixes. Okay. A1E. Wait, A1E is probably with A1. No, it's not. What? Why is it not? I need it in pound mole. So pound mole is not here. Oh, tables and English units. I see. It didn't let me jump to it. Oh, there it goes. Wow, that is like kind of crazy. Well, it's not that crazy. It's just a table. Here, look. Look, that's a table right there. That's not a table. Sorry. It's just this. Okay. Are we ready to multiply some numbers? Who's ready to multiply some numbers, chat? H2, N2. 50 points for whoever can get the number. I don't know, where is it? H2. Pound mole 2.016. I guess, is it pounds per mole? Pound per pound mole. I don't know what a pound mole is, I guess. Yeah, I don't know. I'm not gonna try and guess. I don't know what it is. What other numbers did I need? Oh, fuck. I was looking at it, and then I stopped looking at it. Oh, wait. It's here that I need it. I'm all over the place. H2N2. Nitrogen. Here, we'll go back to good land, and you guys don't have to see this garbo. There we go. 28.01. Pound per pound mole. Then we have NH3 for the other one. Oh, what is that? Heptane? Something like that. Some heptane, hexane. I don't know. I'm gonna turn the gain up just a little bit. Oh, no, what? Propane. 44.09. And then NH3 is... oh, right up there, ammonia. I don't know my formula names very well, let's be real. I don't do a lot of chemistry. I really have to write 20 kmol, 50 pound mole. God, it really... in 50 pounds, so we want pound mole? So if we say 50 pounds, don't we have to flip it over? Probably. It's probably flipped over. My friend is grading for this class. I told her I would draw her something. It was also really funny. There's one guy who asked, he was like, oh, what's the pressure volume diagram? Is that like a control volume diagram? And the professor was like, oh, just ask the grader. I was like, what? You don't ask the grader that. This professor's crazy. I was like, dude, you can't even answer like just say no, it's not a control volume at all. It's like a thing from physics 2. There's my angry little damie. My feeling when unit work. If he sees this, actually, I don't really care. I emailed my professors. I was like, please don't give extra credit for answering questions in your class, because I just stopped giving a fuck. I'm gonna be real. I don't pay to go to college and not like. I'm not just gonna sit there if somebody's like being very silly. If you're a student or if you're a professor. It's like I'm giving up. The 50 pound mole. Or 50 pounds of, I don't know, let's say H2 is first, right? Equals 1 over 2.48. Yeah, that's right, okay. I wrote the same thing. And 250 divided by 28.01. Maybe it's like ASMR, you know? It's like we're doing this little, we got a little sand garden and we're shoveling it clean. Writing out formulas that really don't need to be done at a third-year engineering level, but I digress. Four. The MATLAB thing was cool. That was fun. It was fun to figure that out. I really want to try out the other MATLAB stuff. I have a feeling this getting it into state space is going to be the hardest part of the first activity, but maybe there's some harder stuff, because I know we have to derive the formulas, but like, I don't see how it could be that hard. I'm so excited to see how it's supposed to be hard. I know that sounds crazy, but it's like, that's done. It just seems like it's so easy that I'm like, I don't know, you know? Alright, we can do this one. Specific volume is not hard. I figured it out. Also, the other thing that I realized was the intensive properties that he defined were the same type of intensive properties as in fluids. So extensive properties are dependent on the whole mass. So like if we have an object, it's like the temperature of the whole object or whatever, right? So it has like a temperature, it has a mass, it has, you know, like a volume, it has all this stuff, and then if you want to normalize it and go into the little bits, that's when you get your intensive properties, because they're like inside properties. So that's when you normalize everything by the mass. So you have, you know, volume normalized by mass, and well, temperature doesn't get normalized by mass really, because the temperature is just like an average kinetic energy. So it doesn't really, you can't add up all the things that are temperature. And you know, you have like a pressure that's like at that point. But yeah, he explained it in kind of a weird way. I think he might be defining a subset of that category, but the thing with specific volume is he was like, oh, intensive properties are properties where if you add them up, you can't add them back up to the whole. But then I think he also said specific volume. Wait, let me see. I think he also said specific volume was an intensive property, which I think it is an intensive property. But according to his definition, that's not right, because if you add up all the specific volumes, then you would just get the volume, because you're adding up all the little parts of... I don't know. I'm not gonna lie. It was a little... his slides were a little wrong. Let's see. Lecture 0? When was... wait, that was the last one. Lecture 2. Nope, that's not it. That's not it. Uh-oh. Did he not upload the next one? Oh, he did. Okay, good. Yeah, let's see. Intensive properties. Wait, no. It was this one that he defined it in. Second lecture. I just forgot, because he defined so many random things. Where is it? It's hidden. Why is it hidden? What the, wait, what? When did he define this? Am I tripping? The what? Wait, no, wait, what? Specific volume is defined as the reciprocal of shhhh. Wait, what? Wait, what? Thermal equilibrium. Wait, this is not it. Did I really just zone out so hard skimming this? Damn, I mean, okay. It's kind of hard to read. Primary dimensions, secondary dimensions, yeah. SI, sure. This is units. Was it the first lecture that he defined it? How? No way, no way. He did not define it first lecture. Maybe he did? Oh, he did. Okay, geez. Extensive mass, volume, and energy are extensive properties. Intensive properties are specific volume. I mean, I guess if you don't have a consistent density, then you could say that specific volume is not an intensive property. But do we have compressible fluids, compressible flows in thermodynamics? I thought that we don't do that. Wait, maybe, okay, maybe that's not true. We have compressible, but I don't know if we have varying density. We tend not to do varying density in fluids. Except at like boundary layers between fluids. Because there were some things where I was like, oh, does this thing work if you have a varying density using da-da-da-da? And he was like, yeah, this is not this class. And I was like, oh, okay, geez. So, I don't know. Alright, 2 pound sample. This is pound mass or pound force. Now I gotta look and see if they mention a pound force with an F somewhere. After summary, no. Where's pound mass versus, do you say pound force anywhere? Yes, so pound is a pound mass. Just write an M, guys, please, please. For my safety. For my sanity. Pound mass. My safety. No, I'm gonna blow up if there's no pound mass, dude. I'm gonna lose my shit. Okay. 2 pound sample of an unknown liquid occupies a volume. The specific volume in pound per feet cubed. Feet cubed per pound, sorry. Oh my god, are you kidding me? It's just the density and the volume. It's just 2 numbers divided by each other. I don't know the symbol for a specific volume. Let's look that up. Symbol for specific volume. A lowercase v. Ooh, that's not gonna get confusing at all. V equals its volume per mass. I wonder how this could possibly work. 62.6 inches cubed. Looks into the camera like I'm at the office. Bro, please. One foot cubed. Oh god, okay. Just end me now. Well, I'm an engineer. I got this. I'm so smart for this. I really cooked really hard. Well, at least I can check with the density to make sure that's right. I think for V, I'm gonna do that. That's what I did in thermo. I kind of like it, because it denotes it from velocity. Although I guess we don't really need a velocity. Maybe it's because we don't need velocities in this class as much. That's kind of funny. Alright, so now we flip it. No way. Wow. Wow. Absolutely scintillating. Oh, whoops. Divided by 62.6, not cubed. Oh, no, chat. I'm failing in this class. I can't multiply these numbers together. Wow, and if I do this to the -1, it is that. Okay. I just wanted to make sure. I mean, I might as well just do it out twice to make sure I didn't multiply wrong. 0.21 pound per feet cubed. I realized I didn't follow my own advice. I really should do mass. There we go. Sorry if you can hear my chair and everything squeaking. Alright, let's do this one. Oh, this one should be actually a little fun. You know, it's a little hard. And by a little hard, I mean it's really not that hard, but it's fine. There we go. Alright, so vertical piston assembly containing gas is placed on hot plate. Piston initially rests on the stops. With the onset of heating, the gas pressure increases. At what pressure in bar? In bar. So it's 10 to the 4th, I think. Is 10 to the 5th is an ATM? We're in meters. 10 to the 5th is a Pascal. A Pascal is 1 ATM? Question mark. That might be wrong. That might be wrong. I think it's 10 to the 5th Pascal is 1 ATM. So 10 to the 4th. I don't know. We'll figure it out. We just have to do it. It's really easy. It's quite simple. So we're gonna have our little thing here. It's gonna have some sort of mg, and it's gonna have some sort of force from the pressure. from the gas expanding, heating up. I like how they labeled this. Why did they label it positive and negative? just in case you guys needed to know that, just so you know. Oh, PATM is 1 bar, that's nice. You know, I guess it'll be gauge pressure, or... Did I say gauge pressure? They kind of imply... Oh, wait a second. That's why they said that. Wait, but if we just work in ATM, it doesn't matter. I'm gonna make a note. Assumptions. We start our assumptions list, chat. Assumptions. It's not really an assumption. It's more of like a... I just put it at the top. Because if it's pressing up from the bottom at 1 ATM, then we just don't have to worry about it. Because the gas is also under atmospheric pressure. Anyway, we just need to say the force of pressure equals mg. When it comes out of equilibrium, then that'll... the magnitudes there are fine, as long as g is not a vector. I guess I should probably... to be complete. So, force of pressure is pressure... No, don't cut the whole layer. Pressure equals force over area. So if we want to do that, we're going to multiply the area times the pressure equals mg. So the pressure is going to be mg over A. Very straightforward. So that'll be the mass of this, 50 kilograms, times 9.81 meters per second squared over, and then our area I think is also given. Yeah. 0.1 meters. Meters cancel. That cancels. We're gonna get... what are we gonna get actually? We're gonna get... Let's see, kg... kg per second squared? Yeah. And this is not in... This is in... What is this in? Pascals? kg per second squared? Is that right? Force over area, Newton over area, Newton over meters squared would be... Let's see. Pascal definition, unit definition. I'm pretty sure it's that. Definition. 1 Newton per meter squared. Which... Per meter, wait. 1 kilogram per meter per second square? Wait, what? Oh, did I miss a... Wait. Oh, meters squared. There we go. It doesn't really matter for the numbers, but it matters for my heart and soul. Oh, that's quite a lot. That says a lot of Pascal. So Pascal, I guess 1 bar is... How much is 1 bar unit? Just in case. What is 1 bar in units? 10 to the 1, 2, 3, 4, 5. What? I guess it's 5. Wait, he said 4. Wait, what? He literally said it was... Am I tripping? Wait a second. He might have... He might not have said this. He might have said that... I thought he said a bar is equal to 10 to the 4th. Where's the bar? Where's the bar? Pressure. SI units. Wait, no, here. I swear to God, if he said it was 10 to the 4th, I'll be like, bro, please. Pressure. Okay. He didn't write it down. Nice. Cool. Awesome, actually. Maybe it's in here. Where's the bar? Well, I guess it's just gone forever. It's gone forever. Never mind. It's 10 to the 5th. Sure. 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 So this divided by 10 to the 5th. 0.4905 bar. Just asked for the pressure, right? It didn't ask for anything else. I think so. Yep. The last one's a PV diagram, I think, which it's been a while, but I think I can do it. How long has it been? Oh, actually, I just realized that it was more than a year. A little embarrassing. Nah, we can do this. We can do this. Let's do a big boy. The gas contained within a piston cylinder assembly undergoes 4 processes in series. Constant pressure expansion at 1 bar from V to V. Alright. So, we have V here and P here, if I remember correctly. Let me check that real quick. Oh. Energy in first law? Is it in PV? Yes. Cool. So constant pressure expansion at 1 bar. So I guess we'll just... I don't know, we'll put 1 bar here. That seems... no. 1 bar here. This is 0. And then 2 bar here. Cool. And then 1 meter cubed here. 2 meters cubed here. Kind of a giant graph. I didn't mean to do that. Let's cut this down a little bit. And cut this down a little bit. And then I'll scale it up after. Process 1 to 2. Okay, so from V equals 0.5 to V equals 2. So this way. And then constant volume to 2 bar. Yeah. Okay, constant pressure compression to 1 meter cubed. Okay. Compression with PV1, V inverse constant. PV inverse constant. What does that mean? That means that the... it's either gonna look like this, or like this. I mean, it's not gonna look like that, so we can kind of figure that out at least. But PV inverse, so I guess our slope is gonna normally be rise over run. So the slope is constant, but the slope, oh, wait, that just means it's a line. Lol. There we go. And it's compression, so we're going this way. I think it's that. I can always update it later. Let's go, chat, let's go. I can't even do the other problems that he assigned because he didn't even assign them yet. Let's go. Should we do EE? Should we just do a full gambit every single class? It's kind of funny. I feel like it's kind of funny. I can try. Oh, this, ooh, wait a second, this one, ooh, I think I actually messed this one up. I'm not gonna lie, I think I messed this one up. Let's try this one again. Because when she did an example of it, like, after I did this, and then I said, oh, I see. You gave the exact problem that we did, but I did it when I didn't know how to do it, so we're gonna... Basically what she did, I can remember, it's been a little bit since that class. I probably should have just done it right after that class. That would have been really smart, and then I didn't do that. So we're going to take out the diode. That was the first thing. I actually did that right, and I was like, oh, okay, cool. So diode removed. We want to find the voltage here and the voltage here, so this is ground. The VB equals 10. So right now the voltage here is 10 volts. Because this is 0 volts. So we just need to find the voltage here, which is the same as finding the voltage here. So to find this voltage... Oh, the other thing she did was she like replaced all the... She replaced all the batteries with like wires. I was like, why? Oh, because she said to find a Thevenin equivalent, that's why. But she didn't short the voltages, she just put wires there? Which... Wait a second, let me think. Because for a current source... Oh wait, maybe I goofed it. Maybe, I mean, I didn't try and find the Thevenin equivalent, but I guess you would use short voltage sources for the Thevenin equivalent. And then... Yeah. Okay. So we have to find this. We don't know what that is. And then what we did last time, chat, was like, I just added the batteries together, I think. Oh wait, there's a resistor here. Oh, that's why. It was because I didn't use the resistor, that 10 ohm resistor. I said it didn't do anything, but it does do something. It's these two are in parallel and these two are in series. So we can collapse. Let's find the Thevenin equivalent. I'm gonna do that. So, oh wait, never mind. There's a voltage drop here too. God damn it, we can't do any of that. We got lying. Because the battery's here. Oh, I thought it was easier than it was. Oh no. Okay. We know this is 10 volts. Anyway, let's just find the Thevenin equivalent. So we're gonna find the Thev. And that'll be basically boop 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 boop. Boop 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 boop. Boop 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 boop. Boop 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 boop. And the load is here. So we have, what do we have? These two are in series, so that'll be, sorry, these are in parallel. So 5 and 5, so this will be like R dev equals 5 ohms plus 5 ohms over 2. This music. Plus 10 ohms. So it equals 15 ohms. Instead of, I'm pretty sure I just had it equal to 10 ohms, which was not right. And the other thing we have to do is then we have to do superposition actually to figure out the different voltages there. So I didn't do that. Which, you know, that's not great. Wait, let me actually, no, I don't want to look it up. I was gonna go look at my notes. I was gonna cave, but I'm not caving. The opposite of caving. Okay. So what did she do? She got rid of the other voltage sources. But she left the resistors. Okay, that's what we do. Superposition. So we have this one, and then just this. And then she was trying to say like, okay, what is the voltage here and what is the voltage here with this source? I think. I want to say that. So for this one, this was always the worst part for me for Thevenin circuits, though, I'm not gonna lie. I like never really knew how to do this. Because I never knew when to not think about this. I think in this case, this doesn't exist. There isn't any current going through here. That I do know. There's only current going through here. Which means there's a voltage here. but 0 volts here, I think. The voltage here is V equals V1. I guess I'll do V like that. V that equals V prime V1 equals IR, which I don't know the wait a second, I don't know that though. Wait, how do you wait? Okay, the equivalent R equals 10 ohms. Yeah. But I don't know this, I don't know the current. I know the voltage is... I know this oh, it's a voltage divider. Oh, it's a voltage divider. Okay, wait, so that's gonna be half of 5, right? Well, what is VA? VA is 12. So V equals... Guys, I'm sorry, this is scuffed. 1/2, or like 10 over 5. No, 5 over 10. 5 over 10 times 12 volts equals 6 volts. This seems so up. I swear, I feel like I'm making this up. I swear I'm not making this up. Okay, it kind of seems like I'm making it up. I'm kind of making it up, but I'm not making it completely up. This one, the same thing happens. But I don't understand, because there was one time where she was like, oh, this resistor has stuff going on. I was like, how? It doesn't have anything. It doesn't. Maybe hers was slightly I don't know. We're gonna try. This is my valiant attempt. There's no current going through this resistor. It's basically nothing. So V... Oh wait, maybe it's the third one. Wait a second, because there's a battery here. Wait, no, but it wouldn't want to flow this way. Yeah, I don't know what she's talking about. Maybe because her resistor was here. And so when she had the battery, it looked this way and it saw stuff, but there's a resistor in the way, so there's not going to be any current or any voltage that wants to be over there. Right? This is 0 volts. It doesn't want to go this way at all. It just wants to go this way. Because, yeah, that makes sense. And then... it's another voltage divider. But it's negative. Or... this is 5 volts, so... 5 over 10. Negative 5 over 10. 5 volts equals negative 2.5 volts. We're still at 0 volts. We're going strong. That one's nothing. And now we have a resistor here. Oh, I drew a line there. A resistor here. And then a battery. But I don't know if this battery does anything. Like, where does this battery want to go? I guess around here still, right? So, but it, like, wants to go this way. Chat, I don't know about this one. I'm gonna say 0 volts here. No, it would be negative. It'd be negative. But the question is... if it's negative, it's getting stepped down still? Or getting stepped up? I guess it's getting stepped down negatively? Oh, I don't know. Oh, I did not... my EE was not good enough for this. It's still a half. And VB is 5? Oh... no, VB's not 5. VB's 10. Sorry, I was doing the math quickly in my head. I don't know. So then total. Then we have 6 minus 2.5 minus 5 equals negative 1.5. We have negative 1.5 over here, and the diode is going this way. 0 volts. Not on. I think. Can I check? Is there an answer? 8.9? Wait, we can look. Oh my gosh, we can learn. No way. I'm not used to this. Where is it? No, can it go to recent? Where's the recent PDF? Please. Thumbnail, print, save as, home. Find, close, open. Electric, yes, here we go. And then answers. There's no question answers? What? Wait, they don't have answers in this book? You can't just check your answers? No, they've got to be kidding. There's got to be answers somewhere. Preface, guided tour. Focus on measurements. No, wait. I'm looking in the contents. There has to be, like, we gave you some answers. Bruh, why is there no answers? No. Are the answers after the chapter, maybe? No, they aren't. No. Well, I guess I could just look it up. Let's see. What is it called? It's called Engineering, Electrical Engineering Principles and Applications of Electrical Engineering. Okay, I shouldn't just search answers. Maybe she actually posted them. Maybe she's cool like that. She's probably not cool like that. Syllabus? Oh, no. Wait. Oh. She did. Wait, it's locked. Oh, I guess she wouldn't just post the answers. Yeah. That would, okay, well, at least I can check it sometime. I thought she wasn't gonna post them, and then I was like, oh, okay, well, ooh, that would, ooh. Well, honestly, that's all I got. That was a lot of stuff. That was a lot of good stuff. I have a meeting to get to, so I should probably go to that. I'm gonna be streaming again Tuesday. And we'll be doing probably dynamics and thermo. If he posts the thermo, probably not thermo, probably dynamics, intermediate dynamics. I mean, I guess I could just try and go ahead and do the dynamics. That would be kind of funny. But nah, Tuesday's a good day to start. Because I have one lecture and then we start. I can start doing some of the problems. At least the first two. And then Thursday I could do the other two. Alright, well. See y'all then. I hope you have a lovely day, lovely night. And hopefully we stop just having to multiply two numbers together. Except for this. This is hard. I really need to see some of these. I need to practice with some of them and see how to do the proper Thevenin equivalent, because I never really got it, I'm not gonna lie. But yeah. Alright. See you guys later. Bye. Goodbye.